So we are very happy today, this afternoon, to have Professor Shinsuke Abe to give us this talk on the Dear Moon and lunar impact explorations. I asked him to give us an update on his application to become an astronaut going to the moon. Would you do that? Would you say something about that? I hope so, right?
Yeah.
And but then I should say that Professor Shinsuke Abe now is a professor at the Nihon University. Before then, actually, he was a assistant researcher at NCU, and we are very sorry that he returned to Japan. How to say that to inherit his professor's laboratory. Which is a very important thing, very good thing. So now he is very busy. He's very busy on the asteroid mission, and then the many other things. And he himself is an expert on meteor stream observations, and therefore he is interested in. He is the PI on the camera experiment to look at the impact, lunar impact flashes. That's his talk, and on the CubeSat. So it's extremely interesting. Another thing, of course, is how's your family? Because Mrs. Abe, she's from Taiwan. I want to say hello to her also, and your family. Seems okay. Can you start now your talk?
Okay. Thank you for detailed information, and thank you very much for inviting me to this opportunity. So today, I will talk about our latest, the small CubeSat mission, which is about to launch to the moon. And also, I'm one of the candidates of Dear Moon project, which will be launched by SpaceX Starship and promoted by Japanese millionaire. So first of all, you can see my 1-minute movie here.
Hi, my name is Shinsuke Abe. I'm an astronomer and professor of aerospace engineering from Japan. And I specialize in flying rocks in space like asteroid, comet, meteors, and meteorite impact flashes on the moon. I love space so much that I became an astronomer and developed a camera on small spacecraft Icarus that will be launched by the NASA SLS rocket to take pictures behind the moon, which is a thing for us astronomers. In order to help people think about the meaning of human birth in space and the importance of embracing space challenges, I would love to remind us and Japanese-speaking space sidekick, and also share our journey as virtual reality content. The VR space travel company, Starhouse, will help us with promotion and getting millions of people involved. You should choose me to make a breakthrough in space travel. Take me to the moon. Space rocks.
Okay, thank you for watching my 1-minute movie. So this is actually the promotion video as one of the selection, the video, which is now on the way for the selection. So I'm not sure the final results. So I'm now waiting for the answer from Mr. Maizawa. But however, he is now in Russia to train himself because he is going to the International Space Station this December. Okay. Anyway, I will talk about the update in detail later. So these are our missions, mostly working by my laboratory. And as you know, the Hayabusa 1 and the Hayabusa 2 explored a small asteroid, Itokawa and Ryugu, and fortunately the sample already came back from Ryugu, and they just started detailed analysis. And also the next Japanese asteroid mission is so-called Destiny Plus, which is going to the active asteroid Phaethon as a mutual sure permanent body, Gemini. So this is not rendezvous mission, but it's a flyby mission because this Phaethon is very eccentric orbit. And we are also working on the ECRES, so I will talk about this mission today in detail. And one of my colleagues is working on MMX for developing the camera on board. And I'm also a member of Artificial Mutuals collaborating with the Japanese space venture, AIR. So unfortunately, the first satellite was failed, and the second and the third satellite will be launched end of next year, and we will start the artificial mutual service in 2023. So so this is our study of lunar impact flash from ground-based observations and also laboratory experiments, and finally our small spacecraft Equilius was established, and we just shipped our small spacecraft to NASA Kennedy Space Center. So actually, last night we did the final electric function check and remotely. So everything is going well, and we are waiting for the launching. And my laboratory is also working on the mutuals, and this is one of the most sensitive CMOS sensor on board. This was developed by Canon commercial industry. And the main purpose is to search for dark matter. Dark matter material. One of the dark matter is the candidate is so-called, I forget the name. So there is a particle and which can enter the atmosphere, and by theoretical model, it can see as a very fast mutuals, like 200 kilometers per second at the altitude around 20 to 30 kilometers. So this camera has a capability to detect such faint mutuals, including interstellar meteoroid. So the DIMIS is a international collaborative project, and we have 5 these systems. We plan to put these system to U.S. Utah Desert this year or next year to start our observation. Now we are checking the automatical the remote observation of this system. And we are also interested in very faint mutuals. Usually, faint mutuals can be detected by such high large aperture radar. So we are using the so-called Mu radar operated by Kyoto University. And recently, we succeeded to make a triangulation observation using simultaneous observation using Mu radar and optical telescope. And the Tomoe Gozen CMOS sensor. So this is the same sensor developed by the Canon, and the most sensitive camera so far in the world, operated by normal temperature, and which can detect like 18th magnitude fused stars with 0.5 second exposure time. And in 2023, you can see our artificial mutual, not only over Japan. I plan to make a shooting star over Taiwan or somewhere in the dark sky area. So I will ask you to observe scientific observation using your equipment. So we are now testing using the laboratory experiments like arc heated wind tunnel to test many particles to enhance the light and to control the color. And Destiny Plus, which is just accepted as a JAXA's offshore mission in this May, and we started to make the camera, onboard camera, and the filters. And this spacecraft will be launched in 2024 by using Japanese solid type rocket Epsilon, because solid type rocket is not so powerful like liquid type rocket. So this is a kind of technological demonstration mission to use the solid type rocket to reach the small bodies using many flybys between Earth and the Moon, and it takes 1 or 2 years to escape from Earth-Moon field. So it takes time, but this is the first demonstration. And finally, we will make a flyby with Python to observe not only using onboard camera, but also this spacecraft has an onboard dust counter developed by DLR, Germany. So same as the Saturn's mission. So before this mission, we already have information from dust, like spectroscopy of Geminis every year. So we are now checking the volatiles in this particles, materials. So this is a summary of size distribution of various solar system objects. Because the solid materials that form the solar system have undergone the repeated accumulation and collision disruptions to produce present-day planets, satellites, and small bodies like asteroid, comet, meteoroids, and dust. So the size or mass distribution function reflects the evolutionary history in the solar system, which has reached an equilibrium state nowadays. So however, the size distribution of solid materials has not been statistically and uniformly connected as a single line because of a wide range of observational wavelengths, and from visible light to infrared light, and also radio waves using radar, and from remote observation by ground-based telescope, and to in situ measurement by spacecraft. In addition, their material chemistry and orbital evolutions are not well known. And we can investigate these particles using different ways, like high power and large aperture radar, like Mu radar, and optical method. And today's topic is lunar impact flash, which is sensitive in the size range between centimeter to several tens of centimeter. So this region is a just bridge between meteoroids and asteroids, and one of the important part to identify the size distribution. And we are also interested in the interstellar particles here. So actually, this region is somewhat this size frequency distribution of interstellar visitors from dust to meteoroids and asteroids and comets. And so here it's indicated by overlap, which refers to the interstellar particles related from interstellar comets after having being transported into the solar system by their parent body as like a hitchhiker through the local interstellar cloud. So because these are very fast meteors, and it's still not known by optical method. So now the most sensitive CMOS camera can detect such faint meteors. This is one of the CMOS sensor developed by Canon. So the project name of this mission is Tomoe Gozen. Tomoe Gozen actually is a famous female warrior born in Kiso region, where this observatory is located in the Japanese literature. And so 84 CMOS sensors on board on the Schmidt telescope, which diameter is 1.05 meter with focal ratio 3.1. And actually, this has a large field of view, like 9 degrees across, and 84 CMOS sensors covered about 20 square degree. Of course, there are many gaps, but it can cover a huge area. And we can use 16-bit fits format, and frame rate is about 5 megabyte per frame, and it can reach to 30 terabyte per night. So it's a very huge data set. And this is very powerful system to record the sky like a video with very high sensitive cameras, which can sensitive around 18th magnitude for 1 second exposure with signal to noise ratio around 10. And this system has no filter, and which is similar to G-band of Gaia filter. This is just an example of, this is the video rate of this using this Schmidt telescope. So you can see very faint, long-lasting train after the bright meteors. So this kind of video astronomy is the next generation method to discover some transient phenomena like gamma ray burst and remnant of black hole and so on. And the meteor is one of the target using this system. So since 2018, we try to make a simultaneous observation using 2 wavelengths, radar and optics. So radar is a MIR radar operated by 50 megahertz UHF band with the 330 pulse radar, which can detect the very faint meteors. So, but we are not sure the exact magnitude. So this is ideal to make a triangulation observation using optical telescope. So fortunately, the distance between 2 observatories are about 170 kilometers, and we can tilt this telescope to about 30 degrees from horizon and to detect the meteors with a distance about 200 kilometers. So this is a radar system. End of last year, we also did the spectroscopy aiming to the Gemini's campaign. So one of my students is now analyzing the data. So this is already published our result. So firstly, we identified the relationship between radar cross-section. Radar cross-section is a power reflected by the small meteoroids electrons, and then converted to the exact magnitude observed by the Schmidt telescope. So this relationship looks like a linear function, and we can use this relationship to entire data set. We already have more than 150 new radar detections, and then finally we can get this the luminosity functions of sporadic meteors. And we also can convert from luminosity by using a simple model to the mass. So this is a previously suggested model like Grun from 1985. This is the most famous size distribution of interplanetary dust. And the flux of meteoroids at the top of Earth's atmosphere, as reported by the Grun and also Brownlee is here. Brownlee flux was derived from the stratospheres, the airplane observation, and also ground-based meteor observation summarized by Seplehar, Czech Republic, and Halliday also summarized the Fireball network data. So with so I overlap our final result, converted from magnitude to meteoroid mass. So our result shows the very close to the Grun model, and of course there is a turnover because of the limiting magnitude here. So we can now have this method to observe very faint meteors, small particles. So now we are trying to identify the size distribution of Geminis because of next Japanese mission, Destiny Plus. Okay, so this is the small particles. Now we also interested in the large particles between meteoroids and asteroids. So this gray portion is proposed to size distributions of this range by using lunar impact flash observation from several authors, Orlitz, Sachs, Mediodo, and Lembold. So this size distribution still has large uncertainties, like probably one order of cumulative number of colliding with the Earth. So that's one of the motivation to monitor the lunar impact flash to investigate the size distribution here. So next part, I will explain CubeSat, so-called Eclipse. So Eclipse is an equilibrium lunar Earth point 6U spacecraft, and which will be the world's smallest spacecraft to explore the Earth-Moon Lagrangian second point. So this EML2 is just behind the Moon, about 40,000 to 60,000 kilometers from the lunar surface. This spacecraft will be launched by NASA SLS rocket. Now the name is Artemis 1. So which will be the first flight of SLS and scheduled in late this year. And the scientific instrument on board Eclipse will be the first time by the nano spacecraft. And this is our camera, Delphinus, Lunar Impact Flash Observation. And the main mission is a so-called Phoenix to observe plasma sphere of the Earth from far place. So this camera is sensitive in far ultraviolet to monitor the hydrogen plasma to image the Earth's magnetosphere using the hydrogen. And interestingly, this spacecraft using the water as a propellant, and it has 1.5 or 2 liter, like a bottle of water, liquid water inside, and using the nozzle, the liquid water propellant can change this not only attitude but also the orbit itself here. And yeah, so you can see FUNACET or 2020 paper in detail about this spacecraft. And also we also a huge, not huge, such huge, but large solar panel. So the first plan used this only this size, but we need more power, so we put another extra solar panel here. Actually, Eclipse is the name of constellation. It's a pony in the summer constellation, and Delphinus is also a small constellation next to Eclipse. So that's why I named detection camera for lunar impact phenomena in 6U spacecraft, Delphinus. So originally, the development period is only 1 year. I was noticed by University of Tokyo and JAXA. That's why basically we use the commercial-based and already established technology in the space, like Vatex sensor, but however, the lens itself is designed from the beginning. So this is the summary of our camera. The spectral sensitivity of this sensor is between 400 to 900 nanometer region, and mainly the visible region, because the lunar impact flash cause in this wavelength region, and also near infrared. And the sensor itself is not the state of art. It's a very old-fashioned sensor, like VGA, 660 pixel by 450 pixels. But the pixel size is relatively large to detect the faint phenomena. And we developed the new lens, 50 millimeter focal length and 1.4 focal ratio. And field of view is like this. And this camera has three observing mode. One is for lunar impact flash with exposure time 60 frames per second. And we also has another observing mode to monitor some near Earth asteroid or temporarily captured orbiters. Sometimes ground-based observatory can detect such interesting TCO, and we can try to detect this very near Earth object within the lunar orbit. So this is another function. And also very fast exposure mode. So if we have enough fuel, we will try to rendezvous or flyby with near Earth object in the future discovered near Earth object. So there is a strong some limitation for the observation. So our camera, we can accept solar angle larger than 45 degrees, and we have a baffle in front of the lens, longer baffle. And also, we need a dark night portion, more than 25%. It's 25% of this side of the moon. Otherwise, stray light is too strong to detect the faint lunar impact phenomena. And lunar surface, the distance less than 40,000 kilometers is preferred, but it's not the orbital schedule. We have several orbital plan designs, but the final design is not fixed yet. Okay, so we also plan to make a campaign observation, which can observe both from eclipse and the ground. So we have such opportunity because we are not going to the EML2 point. We are going to the halo orbit around the moon. So anyway, polar and far side observation are very unique because of this will be the first time to monitor lunar impact in this region. So from ground-based observation, Earth-shine, so the night side portion is very limited. It's about 3 to 5 evening observation session between new moon and the first quarter, and also 3 to 5 morning session between last quarter and the new moon. So this is another reason why we are going to the space to monitor this phenomena for a long time, and continuous observation. Another new technology, we use the so-called Benta black. This material is the darkest artificial substance ever known, which can absorb more than 99.8 or 9% of radiation in the visible spectrum. So I think in the Japanese space mission, our camera is the first mission to use this material.
Phantom Black is designed to reduce unwanted stray light and is highly desirable in space applications, but can be used in a wide range of other applications, including high-performance infrared cameras, sensors, scientific instruments, satellite-borne calibration sources, star trackers, and telescopes, and can even provide a unique aesthetic effect in certain high-end luxury products like watches. Oh, and to all you YouTubers out there, if you're thinking of buying some Vanta Black for videos, don't bother. It's not sold to private individuals, as the coating is subject to UK export controls. Anyway, that's the end of this video. Thanks for watching, and we'll see you next time. Bye-bye.
Yeah, since last year, Japanese branch company can treat this material. So now it's very easy to order the Ventabrak in Japan. So probably for space usage, we will use this material again. Okay, this is the orbital plan. The primary objective of this mission is to demonstrate the trajectory control technique within the Sun-Earth-Moon region with low energy transfer using the water. And for the first, this mission is for the first time by the nano spacecraft using the water propellant. So for this purpose, the spacecraft will fly to a libration point and libration orbit around the Earth, Moon, and finally reach to the EML2 by using the multiple lunar gravity assist. So okay, so there actually these are delta V, the critical trajectory correction maneuver is there. So anyway, it takes about half year, less than 1 year to reach the EML2, so we can start observation. So this is the schedule of the orbital maneuver. So finally, NASA SLS is going to launch end of late this year. So we are not sure the final announcements, but so far the NASA announced we will launch end of this year. So now we are ready for our mission. Okay. So we took this video as a final check, final shape of the aquarius before shipping to Kennedy Space Center. So now some of people are now working at the Kennedy Space Center for final function checks. Okay, so these are the DLP Delphinus team. So this is memorial group pictures. So however, because of COVID-19, so I ask company people to show up on screen. So we took this memorial group picture. And he is Professor Yanagisawa. He is a pioneer of Japanese lunar impact flash observation from ground base. And this is his final mission. He already retired 2 years ago, and he plans to analyze the data. He's waiting for the data from this spacecraft. And Mr. Fusei is now the assistant of my laboratory. So we are working hard and establish this system. So now you can see the series, the story of the development and of our mission. So the story is carried in the series by online ISAS News. Sorry for only Japanese, but you can see many interesting pictures. Actually, Omotenashi's second payload on board the NASA SLS rocket, which will hit on the moon and to communicate and with crashable technique. So this is another small CubeSat here. This one. So you can see using from this website.
Once Orion is a safe distance away, the fleet of 13 CubeSats will be deployed.
So there are 13 CubeSats. So probably Eclipse will be the first CubeSat.
The onboard avionics box will command each dispenser to
be
release the small
deployed.
satellites, sending each one on their way to deep space destinations such as the moon or an asteroid. Each has a mission that can provide NASA with new key knowledge and test new technologies.
Okay, so I will speed up to explain ground-based observation. So Chriser, actually she visited my laboratory 3 years ago. She already had her talk in this minimum colloquium, and she was so surprised to see my telescope. It's a moving telescope, so-called Gundam, and it's very heavy, 600 kilograms telescope with moving basement. And anyway, so this is 40 centimeter diameter with the focal ratio 3.8, and using reflector we can use 3.0. It's very bright optics, and with 20 centimeter f3.0, the second telescope. We use both telescopes to monitor lunar impact flash. And from this year, we are trying to get the spectrum using this larger telescope. So this is during the Geminis. And Geminis 2018 was very active, and we detected more than 10 events within 3 hours. And this is not only from our telescope, but from Electric Communication University, from Yanagisawa-san's laboratory. So this is just a summary. So I have to submit this paper. And so from very detailed photometry, so we finally get the mass and the diameter of the impactors. So for example, A and F is relatively bright event, and using Holsapple scaling law, impact scaling law, we can estimate the diameter and depth of newly generated craters. So I compare with another main survey telescopes from NASA, Meteorology and Environment Office, and Neliotar from Greece here. And we also, this is NASA. NASA is all using the R band, and Neliotar is using R band and I band. So this is our result. We detect only 10 several, only for Geminis. So, but anyway, I can make the slope of luminosity, magnitude distribution, luminosity distributions. And Professor Yanagisawa did the spectroscopy. This is the first spectroscopy using the transmitted grating. So he put the transmitted grating just in front of the sensor. So this is not the correct way, but anyway, he calibrated using the field star to get lunar impact flash spectrum. And at the beginning of some flashes, so we found an excess of flux at the short wavelengths, with about 600 nanometer region, and which is a hot component about 6,000 Kelvin, and typical temperature is around 2,000 Kelvin. So explained by the single black body curve. So we guess the contribution of a high temperature vapor plume generated by the very beginning of the impact phenomena. So which is very important of lunar impact flash, which cannot be simulated by laboratory experiments. So of course, the Chriser already published this paper. Neliotar also showed 2-color temperature, showed very various temperature between 2000 to 6000 Kelvin. And this is newly data. So actually this observation was done in 2007, but I didn't analyze the data yet. So I asked my student as his bachelor thesis, Mr. Okuyama, get this result. This is very, very bright Gemini's impact, and around 5 magnitudes, very bright. And estimated impactor's meteor's diameter is 15 centimeter. And the generated crater is about 10 meter in diameter. So we identify some, at least one crater from LRO, Lunar Reconnaissance Orbiter data. So we will try to identify another data, crater. Even this observation was before LRO. So this is very huge and probably looks fresh, like white material can be identified. So interestingly, our observation also showed the very first luminosity shows the high temperature. The black body curve is very different from another time series of spectra. So this is another indication of plasma phenomena at a bit early stage, and the later stage continued by the black body and the red part. So for Geminis, we have another information of impactors using the Geminis mutual shower. So this is our paper already published in Planetary and Space Science. So we are interested in sodium as an indicator of volatile. So Geminis is an active asteroid which shows a very rocky material and containing volatile like sodium is depleted. So this is another information of impactor, especially for Geminis. So I skip this part, and yeah, this is also interesting figure. So from Gemini spectrum, statistical analysis of 140 spectrum, which shows no decrease of magnesium and iron as a function of luminosity. It means as a function of size. On the other, sodium shows the depletion at a smaller particle, which means that solar heating is significant to the smaller particle. This is another hypothesis. So we are now working, because Gemini's orbit is very close to the sun, perihelion passage. During perihelion passage, the equilibrium temperature is almost 1000 Kelvin, and using Rayleigh approximation temperature for dust, which also close to the sublimation temperature. So these cause the depletion of volatiles like sodium. Okay, so maybe 5 minutes left. So this is the Slovakian colleague, Peter Pokolonti, published this paper and a lunar impact model. So using the several population from main belt and Jupiter family comet and Halley type comet and all type comet, they can make an impactor model. So this contribution is very similar to the radar observation from ground base because the situation is very similar. For example, you can see apex enhancement around here, and sunward is around 12 hours. It's a lunar coordinate. It's sun direction and anti-sun direction. These are coming from Jupiter family comet, and also you can see some toroidal enhancement, and probably coming from the asteroidal dust. Okay, so this is a impactor model on the moon caused by the sporadic meteors. and also velocity distribution. So recently, Kaguya team identified some water absorption band around the southern hemisphere, South Pole. So on the date around the maximum of Lyrays. So I suggest I ask them it's not caused by Lyrays, because Lyrays impact only northern hemisphere of the moon. So on this date, so there is another meteor shower, the pi Pupids, Tomoza in Japanese, and which can also hit the southern hemisphere around the South Pole. So this is another candidate to make an enhancement of water vapor of their detection during this date. Okay, so now we are doing the laboratory experiments using hypervelocity facility operated by JAXA with a velocity between 6 to 7 kilometers per second. So we established our original method to take the very fast spectroscopy down to 200 nanosecond continuously for about 120 frames. So Mr. Fuse already published our paper to PSS. He investigated the luminous efficiency as a function of vacuum pressure level, and we conclude that there is no significant contribution from the vapor previously suggested by Sachs et al. So our data is consistent with previous value. So you can check this paper to see the luminous efficiency of the event. So anyway, our method is very powerful to see the emission line and continuum line. So now I'm interested in the very beginning emission lines of the lunar impact phenomena. Of course, the laboratory experiments, the velocity is much slower, up to 7 kilometers per second. But even though we can see some emission lines, so for this case we use the carbon material and we can see the swan band of molecular carbon bands here. So we have our model to compute the molecular bands to identify the plasma temperature. So these are just examples. And also we can see the black body temperature decay, and yes, so we are now doing this kind of test. So future plan. First, future plan is this summer we plan to use this facility and to use the water ice as a target. So we will see the evaporation emission lines using the water ice. So this will be the first attempt to see the water ice impact flash in the laboratory. So I know Chris's team already published one paper using the dry ice and water ice. But anyway, we will do the faster velocity impact water ice experiments this August. So future plan. So we have another borometric camera developed by Professor Fukuhara. So using combining with optical and IR camera, we can monitor this kind of phenomena from lunar orbital platform, so-called gateway, or lunar orbiter, using the small satellite. And another future plan is to use the field reversed configuration, so-called FRC plasma facility. Fortunately, this facility is just 3 minutes walking from my laboratory, and I'm a now member of a professor size plasma laboratory. So we now I'm proposing to use this facility to simulate hydrogen production by deuterium interaction. So this FRC instrument can generate like solar wind condition with a velocity of 500 kilometer using deuterium and hydrogen. So we plan to put the carbonaceous chondrite rock or powder as a target here. So we, as you may know, Dr. Nakauchi already published this paper recently, and using laser irradiation to generate water hydrogen using saponite and serpentine, OH included carbonaceous material. So we will test using the more realistic and deuterium is very important to simulate, to generate hydrogen. Okay, so I'm waiting for the Dear Moon crew. I'm one of the Dear Moon crew candidate. So more than 1 million people from 249 all over the world registered, and now we are here, about 120 people, including only seven Japanese assigned. So we submitted 1 minute video for the next step, but somehow the selection process is stopped and there's no information since the beginning of April. So I'm now waiting for the final result. And if I will be selected, I'm going to the moon with Mr. Maizawa using the Elon Musk's Starship in 2023. And probably I can take pictures using delphins behind the moon with like a selfie. Thank you very much.
Yeah, Shinsuke, fantastic. Any questions from the audience? You want anything to ask him to bring with him to the moon and come back and give it back? So if you want to ask questions, please unmute yourself and just ask. So I as far as I can tell, Shinsuke, you have so many things to do. No wonder you're so busy. So difficult to get you down. To give a talk. You mentioned this Nakauchi. Nakauchi, is it Nakauchi? This experiment stimulating solar wind interaction with this lunar glyph.
Mm-hmm. FRC, yeah.
You said the lab is only 3 minutes walking
3 minutes.
distance from you.
Yeah.
Wow. Is it part of Nihon University or?
It's the Nihon University's facility. Well, we need some budget to operate this.
Okay. Well, you're a good friend of this millionaire, Maizawa.
Yeah. I know you are interested in solar wind. So if you have an idea, please give me your idea.
Yeah, I'm just thinking of inviting him to give a talk. Is he a professor at the Nihon University?
Yes, Professor Asai. He is a very famous professor in this field.
Okay, T. Asai, yeah?
Yeah, T. Asai.
I hope I can find out his email address there, write to him. And I said that it was Shinsuke asked me to write to you. So then you said that the selection of this, there must be a Japanese company, the millionaire to the moon. So you have a 15% chance, at least, to go there.
It takes 1 week to go on the back, so I need 1 week holiday from my school.
And what you just wait for the telephone call and say we are going tomorrow, and you just
Actually, he's living close to my house. He's living in Chiba Prefecture, only 20 minutes from here.
Oh, 20 minutes from
Yes.
So everything is 20 minutes to you.
Yeah.
That's great. All right. So if there's no questions from the audience, I think they're very amazed by what you are doing. And
I will visit Taiwan and see you after COVID-19. I already vaccinated. Yeah.
So
Probably
you have no
next
fear.
year.
So come here anytime.
Come
Come here anytime. Just let us know, and then And then you're welcome to visit our institute. You know, to have you could stay here at the as an office, you know, temporary office.
Thank you.
You're welcome to. And you're talking about another CubeSat mission is what's it called? Omoten.
Omotenashi. Omotenashi
right,
is
right.
The second CubeSat on board the Eclipse, on board the SLS. Omotenashi.
Yeah, who is the PI of that mission?
Professor Hashimoto from JAXA. And omotenashi, actually, it means hospitality in Japanese language.
Oh yeah, I think I find it out too. Yeah, because I mentioned it. Yeah. And then Hashimoto, you say Hashimoto.
Hashimoto-san. Yeah, so he's also the Hayabusa, former Hayabusa member. So,
so maybe I will ask him to introduce this mission. Very interesting.
He can probably introduce during this curriculum.
And I will tell him that Shinsuke asked me to.
Okay, no problem.
Maybe I should ask the millionaire to give a talk. You know, if you give me his email,
you can ask millionaire by. Yeah, I cannot ask him directly. Yeah.
Okay, great. If there are no questions, then I would thank Shinsuke again, right? And then the best of luck for your selection. And once we know that you have been selected, we certainly will write to you.
Okay, thank you.
Okay, thank you, Shinsuke.
Yeah, thanks, Aaron. I'm sorry for my video.
No, that's great. You know that I'm sure people will watch it again and again.
Yeah, please visit my YouTube video and click the like. Yeah, YouTube video. You can find YouTube. And Dear Moon or Dear Moon Crew, you can find my video.
I'm sure that the Professor Albert Gong is thinking about making a movie like that, you know, himself.
And actually, we established a new company, VR space travel company. It's a now real company in Japan. We started educational program from elementary school, and also and for adult.
And selling space locks.
Yeah. And actually, we developed, or we already have our own Lunar hall for audience.
Now,
I can invite VR next time.
Yeah. I mean, if you have any, send us your webpage, because we could always ask someone who, I mean, actually, Kinoshita, you know, Decay, he could translate for us. That would be very interested, you know. If you want to have a branch office in Taiwan, you're always welcome.
Okay.
Great. It's okay. Thank you so much.
Yeah, thank you very much.
Yeah. Bye-bye.
Yeah, bye.